So as Andrew gets his laptop set up for you here, couple things. First of all, right after this, we're going to go to lunch, so you have a break coming up pretty soon. Also, all of you who are here today will be getting a Secure AI Engineering certificate after the event. All right, Andrew,
is this working?
Passing off to you.
All right, thanks, Randall. Thanks, Aaron and Denise. All right, I have the coveted pre-lunch spot. Thank you for your patience. Let's try and make things spicy and a little quick. So hopefully you've been coding your apps, using the tools, figuring this out. This was a fantastic tee-up, right? I mean, these are incredibly powerful tools. One of the things we've found at Snyk is that pairing the general purpose LLMs with these sort of specialized analysis tools can really give you the best of both worlds. And so what I'm going to do is just walk you quickly through how we think about this, how we think about the tools and how you can use them, and then also some hopefully exciting but not too exciting live demos where I'm going to do some crazy things that I've practiced but have very little preparation for here. This is, by the way, this is a QR code. I'll show it again later. Feel free to grab this. This will take us to our GitHub repo that has some instructions you can follow along if you don't want to use your own app you've been developing. All right, let's set some quick context. Right. We're coding here, right? We're using agentic development. What does this process traditionally look like, and why are we talking about security? So usually how this works, right? You have an idea, whether that's a feature or a refactor or a new app. This could be a small idea. It could be a large idea. You then go start working on a backend, start programming it up. You then do your UX and your iteration. And then right as you're close to the finish line, you go do your security review. And then you're foiled. The best case scenario is you're foiled, right? Like you find the issues, you go fix them. The worst case scenario being, of course, you don't actually find any issues and you launch an insecure application. I have written a lot of code this way. I've developed a lot of projects this way. I'm sure we all have. It's not awesome. So how do we make this better? The main thing, and this is, again, like part of the Snyk philosophy, is what we call shift left. So take security and move it as far left in the development process as you possibly can. The closer you get it to the beginning, the more effective it is, the cheaper it is, the more time you save, right? As an engineer or a developer, your time is one of the most valuable currencies we have. And if you wait until the end to do the security piece, you're just wasting your own time. And so again, best case scenario, you've wasted time. Worst case scenario, you actually get a worse result or insecure code. Also, there was someone over here who asked a question about securing MCP. This is a great question. I threw in a little lock here. We're going to have some sessions this afternoon to talk more about this. Securing the actual use of these tools is a whole other really important topic. I'm not going to get into it, but as we're throwing all these agents, all these new tools at our code bases, at our really sensitive IP, running these tools in our command lines, that becomes incredibly important operational security as well. So watch that space. We have some cool stuff coming there. OK, so what does this look like ideally? So it's what we call autonomous security. So again, the less work you do, the better. What we really want is that as you write code, it's evaluated for the security issues, and those issues are fixed in that core loop, right? So you don't have to do this sort of separate step. And again, the further left we can push that, the cheaper it is and the more effective. Also, when we discover novel threats, right, that could be a new CVE that's discovered or a new way of manipulating an application, we want to be able to discover those, not just tell you about it in your application, but then just fix it autonomously, right? Why should you have to do that work? And so these two things together are really the core of what we're trying to build with our Snyk Studio product. And so this first piece, that's what we can do today. So this is what I'm going to demo. We'll help you set it up. You can do it as well. It'll be sort of a live workshop. The second piece is really evolving. I'm really excited about this space as well. Watch this. We have a lot more coming here to talk about. How do we actually do this? So in practice, right? The first thing we do is we set up static analysis software. So I'll walk you through setting up Snyk. It's really easy. As an aside, the way I think about it, and you sort of touched on this as well, the way I think about the LLMs is sort of like a computer, right? So in a normal computer architecture, you have your CPU. And the CPU is this general purpose processor. So mathematically, we can prove it can compute anything that's computable. But it's actually kind of inefficient at doing so. It can do anything inefficiently. So what we do is we then plug in these other modules to it. We plug in a GPU. You plug in an I/O coprocessor. You plug in a sound card. These sort of fixed function specialized units that can do one task and do it really, really well and really cheaply. And this is how I think about how we use these agents. An LLM is this incredibly powerful general purpose computational device. Having an LLM do everything is inefficient. It's non-deterministic and inefficient at best. So what we want to do is plug in some of these other modules, right? Think of it like a GPU, but for security. That can then do one thing, do it really, really well, and then offload that computation from the LLM. You sort of get the best of both worlds, right? You get this sort of fuzzy orchestration and problem-solving capability, but then you get the sort of determinism and efficiency of a sort of a fixed function unit. And security, obviously, is what we're all here to talk about, but I think this generalizes. So in this case, Snyk, and we have a whole sort of suite of security tools. I won't walk you through the whole pitch, but you should check it out. There's a lot of interesting stuff. We'll demo a couple of them. Is that sort of fixed function unit here. That set of tools is what we're plugging into the LLM to help it serve us better. Having the tool is not enough. You have to configure it, right? So there is all sorts of different front doors and ways to do this. It can literally like run command line tools. We have an MCP server. I learned yesterday, apparently MCP is not cool anymore. Now it's hooks, so it'll be hooks tomorrow, right? Like the space is evolving super fast. But the doorway, I think, is less important than having this notion of we're building these sort of these agentic interfaces, basically, between these tools we use and your workflows. So today, it's MCP. Tomorrow, it'll be something new. In 6 months, it'll be something new I don't even know about yet. That's cool. The core part of this is we have the awesome LLM. We have the tools. We're bringing them together, and as the workflow evolves. And then finally, again, what we were just talking about, setting up the rules and best practices. The agents are incredible. They are born new every time you launch Gemini, so like give them a head start, right? Don't make them figure it all out from scratch. Evolving the rules and best practices as you go is really important. All right, so that's the whirlwind tour. Oh, I am so sorry. I have candy also. So if you have questions, raise your hand, and I will attempt to throw candy at you. I cannot guarantee it will go close. I'm not a sports person, but I will attempt. All right, I'm going to leave this up for a second just so you can sort of grab the QR code and do it. So hopefully, again, you've been building your sort of application this morning. Feel free to follow along. I think this is always most interesting when you're seeing what horrifying things you put into your own code. That's been my experience. But also, we have this demo app. If you just go and clone this, it has instructions as well as a bunch of juicy vulnerabilities. I promise this app was generated just with a prompt. We didn't tell it to make bad code, but it did. So there's going to be sort of a two-part demo here. First, I'm going to show what we would do to take an existing code base and analyze it and fix it. And then we're going to do hopefully something more exciting where we generate something totally new and see what happens. All right, is anyone still grabbing the QR code? Great. All right. So I'm going to walk you through what it will take to basically set up this application, run a security scan on it, and fix the issues. So let's see. So I have a clean repo. You can see I've been doing this. All right, so I'm going to run this install command, Gemini extensions install, and I'll leave this up here for a second in case you want to type it down. But again, you can copy it from the GitHub repo. And what this is going to do, I actually already installed it because I wasn't sure the Wi-Fi was going to work great, is it will install our agentic wrapper. So that's the Snyk command line tool that actually runs the security analysis, the different types that I'll show you, as well as the interface to Gemini that hooks it all in. So once we've done that, let's run Gemini. And we can see we have our code here for this application. So this is this lets us upload some stuff. That's always fun. There's HTML, there's TypeScript. What could go wrong? So now that we're in Gemini, you can see I have my Gemini.md file somewhere. I actually don't remember where I put it. And then one MCP server. So if we go look at our extensions list, we can see there's now this Snyk extension. And let's do an MCP list. And you can see now we have all of these Snyk tools. So each tool in the MCP context is basically like one thing you can ask the MCP server to do. So what we've done is we've taken each of the sort of Snyk analysis types and exposed that as a tool here that you can run. All right. Is this text size big enough? I can make this a little bigger. Here we go. So we have our application. Hopefully, everyone's been able to run this so far. Anyone need another second to get it installed? All right, let's run a scan, and let's see what Snyk finds, and let's see how Gemini fixes it. So I'm just going to say run a security scan, and let me know what you find. And I have gone ahead and deleted all of my accounts and reset all my credentials so I can show you what the sign-up flow looks like as well. So the first thing it wants to do is run what we call an SCA scan, that's software composition analysis. This basically looks at your code, looks at what dependencies are there, and then finds if they have vulnerabilities. So this is one of the most common ways for your application to become vulnerable. It's not that you write a vulnerability, it's that 3 steps down the chain of some library you're pulling in that you haven't updated in a while, that has a CVE. That's very hard for you to find. And so what we want to do here is just run this analysis and say, hey, are we depending on anything that has vulnerabilities published against it? So let's say yes. I'm not going to do YOLO mode because I want to show you the sequencing here. I recommend just telling it, yeah, let Snyk run, because otherwise it gets a little annoying. But I will show you each of the steps. So it's going to say error folder, you can't trust it. And now it's going to open a browser. Run Snyk trust. So we do this because running the analysis involves actually sometimes invoking some of the build scripts and code yourself. We want to make sure that we're not running random code on your machine that you don't trust. We're going to ask you for an explicit trust step. Once you trust it, once you're all done. All right, now it's going to run again. Yep, allow. It's going to run Snyk auth. And now, because I'm doing in this demo Gmail account, which if you already have a Snyk account created, this won't happen to you. But I wanted to show it for those who don't, what the sign-up flow looks like. It'll just pop you into the browser. I'm just going to sign in with my Google account here. I agree. High five. It's thinking. Sure, email me. All right, asking for access, grant access. There we go. All right, that actually skipped the step I was expecting. So let's see what happens. Live demos. Let's run that security scan. So now what it's going to do is it's actually going to go out and examine the code and find all the dependencies that we have, and then go look up in the vulnerability database and say, are there published CVEs against this? Yeah, I'm just going to tell it to YOLO. I'm tired of doing this. And so you can see if I scroll up, this is a slightly ugly JSON, but we've gone and found 5 different issues in this current application. So these are dependencies we have that have CVEs published against them that could be exploited. And so now it's thinking, it's upgrading. All right, and so what it wants to do here is upgrade, you can see Multer from version 1.4 to 2.0.2. Usually for this kind of thing, the best thing to do is just upgrade, right? If you just stay close to the newest version of all your dependencies, generally speaking, you'll get the best possible outcomes. Upgrading is not always simple. That's where, again, a lot of these tools can become helpful. But in this case, it's not going to be too bad. It just wants to run this diff. Yep, let's just keep going. So now the LLM is actually figuring out how to update our dependencies based on that analysis from the Snyk tool. All right, and now what it's going to do is it's going to run the scan again and see if there's any issues that it still has. Issue count 0. We're good. It's thinking. All right. Should we try something a little more exciting? I think we should. So we can see here what it did. So it updated our dependencies, et cetera. So for my next trick, what I'm going to do is I'm just going to go into the Snyk settings here, and I'm going to make sure that Snyk code is enabled. So enable Snyk code. This should happen by default. Sometimes it doesn't, so just keep an eye on that. You'll get an error if it doesn't. All right, so what I have here is a totally blank directory, nothing up my sleeves. I'm going to attempt to do something kind of insane, which is just do this prompt live and hope it generates bad code. The last time I did anything close to this non-deterministic in front of an audience was 15 years ago at Google I/O, and it did not go well. But I'm hoping it's going to go a lot better today. I've tested this a bunch of times. I would say like 8 times out of 10, it generates code that works and is super vulnerable. 1 times out of 10, it generates just code that does not work. The application just crashes. And then 1 times out of 10, it actually manages to not generate any vulnerabilities. So let's hope, for the purposes of the demonstration, that we get some good vulns. All right, so here's my prompt. So this first piece here, let's open up Gemini. This first piece here is what you would usually put in your Gemini.md. I'm including it in the prompt here just for the sake of the demo. And I'm just going to copy and paste it over. And this is basically just saying when you're generating code, run Snyk on it, and then if you find issues, fix them. And then I'm just going to type this, this prompt. All right, so write me a single file JavaScript node server that lets a user upload an image and a description. Again, feel free to follow along, come up with your own prompt. You can copy this one. Have fun with it. All right, when uploaded, show the user a message with the image and description confirming the upload was successful. This is a trap that I am laying for the LLM. We will see how in a second. When the image is uploaded, it is stored on disk in an uploads directory. A second trap, a very reasonable request. A list of uploaded images is also given on the main page with their descriptions, a third trap, and a link to download each uploaded image. And then I'm going to tell it not to try and run it, because sometimes it gets stuck running the application, and then I have to kill Gemini, and it's sort of annoying. Prompt me to run it manually and verify it works rather than trying to do it automatically. This is not following best practices, right? We should be like writing tests and having it do TDD, et cetera, but that's not exciting. So, all right, let's see what happens. Channeling the force. And so again, this is, I worked on this prompt a little bit. Oh, do I want to run make dir? Yeah, that seems safe. But this is actually a pretty straightforward prompt for an application. Most of the engineering I was doing for the demo was trying to make it so it wasn't generating all sorts of other crap, so to sort of distill it down. Let's run npm init. And again, what I'm going to show here is stopping after each step so I can show you the sequence of events. You actually would want to just let it generate and run. That's sort of a more effective way to do this. All right, let's run npm install. What's it doing? All right, we got packages. Do we have any code yet? Writing server.js. It's interesting. I would say usually it's index.js. Sometimes it's server, and one time I got app.js. It likes to keep me on my toes. All right, so let's see what it wrote while it's thinking. All right, so we have it avoided the first trap, which is the easier trap to avoid. So it did not allow a path traversal vulnerability. Let's see if it. I think it fell into the second trap. So I think there's an XSS here. So before we run Snyk, so again, normally it would be running this autonomously in the background, but for demo purposes, I want to show you what it did. Before we let it run Snyk and figure out what's going on, let's actually run the application and see what happens. Did it work? All right, so an image upload. So let's choose a file. You can see I was playing around with like cross-site scripting with file names last night, which was kind of fun. But instead, let's pick this picture of my dog getting into the garbage. Naughty dog. All right, the app seems to work. It didn't crash. We have our picture. That's my dog. Back to home. All right, so let's see if we can cross-site script attack this. All right, let's upload the same picture. And I'm not a very good script kiddie, so all I know how to do is do alerts. You can see I've been doing this before. Alert, gotcha. Someone who's better at hacking things come up with something much more nefarious. All right, cross your fingers for me. Hey. All right, so we just did, yay, it screwed up. Thank you, thank you. So what we just did here, it's a little small, is a cross-site scripting attack, right? So we were, and this is exactly what Aaron was showing us before. So there's a string the user is supplied. I put some script tags into that, and then that is executed in the context of your browser window, which means I have now stolen your cookies and done something horrible, like order stuff on Amazon. I don't know. And so if we look at the source here, view page source, you can see the description. The script tag is unescaped in the source. All right, let's see if it fell into the second trap. Go back to home. Yep, all right, and on the home page as well, we have our gotcha. So like I said, I've run this prompt a lot of times this week just to make sure this goes smoothly. It is shocking how often this vulnerability is generated. I came into this thinking like, all right, I'll have to like carefully figure out a prompt and like construct it and craft it. I'll have the predefined demo thing just in case it doesn't go right, because it's not, it's not actually going to do this every time. It really does. So again, I encourage you to like play around with the prompts, play around with the applications you're generating. These tools are absolutely amazing. They're trained on our code. Our code sucks. So this is a really fantastic, fantastic way to see how that plays out in practice. All right, so let's let it continue. So let's run Snyk. Oh, it's trying to run the binary. I don't know why it's doing that. No. Run the MCP server I just installed. Thank you. That has not happened before, actually. That's not usually what goes wrong. What are you doing, buddy? All right, it is going off. Something was going to go wrong. Let's just install the Snyk command line so I can show you how this works. And then that will let it do its thing. Try again. Yeah, that's a good idea. Yeah, try that actually. Yeah, use the Snyk MCP server installed via Gemini extension. Discovering the Snyk command, all right. Find name, what are you doing? No, oh sure, you can find, why not? What could go wrong, right? Just letting it run find. It is very confused. Yeah, all right, I'm gonna restart Gemini session. That's a bummer, because I really wanted to show it all in one flow. But it's fine. All right, so now we're back in. So now let's say run a security scan as if you had just generated this code in the same session. So we can see it has, oh no, I'm in the wrong directory. We can see it still has the code here. It wants to run, it always likes to run PWD. Wants to be very sure of where it is in my computer. Here we go. All right. So now it's going to run a Snyk code scan. So what this is going to do is it's going to actually analyze the data flow of our application and discover, okay, you are taking user input you're taking a user-defined data over here, plumbing it through, and actually detect, hopefully, where we actually plug it into the HTML itself, thereby causing this cross-site scripting. So let's allow. Allow. Oh, it's doing both in parallel. That's new. It is learning. Even since last night, it is learning new tricks. So it's also going to do that SCA scan. And so that'll be interesting as well, too, right? It'd be interesting if it generated a set of SCA findings, even though it just generated the code. Oh, it's running Snyk Trust. All right, let's do that. And again, this is one of those things where the training data for all of these models is based on what's out there. So they're going to be trained to use, for example, older versions of packages, because that's what's all over Stack Overflow. And so you'll often see it will generate a very common version, but an older, vulnerable version of a package. And then you can do this type of thing, again, in this loop, so that you don't end up actually checking in a dependency on a vulnerable package. Yeah? Yeah, so what it does, so for the SCA scan, is your, yeah, let's try. Damn it. All right. There we go, yes. Yeah, so what we do when we do the SCA scan is we actually, my boss is cracking up in the back row. I've now embarrassed myself thoroughly. We go find all the dependencies, and then we scan, again, that vulnerability database we have that goes all the way back. And we have an extensive, Snyk has this extensive vulnerability database that pulls from all sorts of different public repositories, as well as we have our own security analysis teams that are looking for new CVEs, new vulnerabilities that are out there in the wild, and then publishing them. And so there's a lot of different ways to hook into that. We have APIs. We have, obviously, this tooling. You can run a command line, and all of those will give you that same sort of analysis. All right, so it wants to do, let's see, I got distracted. Okay, it did something. What did it do? 0 issues found. Okay, good. This is actually great. So it actually generated something where we didn't find issues. But now it's saying I found some vulnerabilities with the Snyk code scan. It always likes to rate limit. I don't care about the rate limiting, but it likes to do that one first for some reason. And what's cool here, so for example, npm will also sometimes flag vulnerabilities. And so you sort of get both of those tools working together, which is fantastic. All right, it's sanitizing. OK, so I actually thought that I didn't think there was a path injection. And there was. So Snyk found a path injection vulnerability here that I didn't see. I don't know how to view this diff. I made the text too big. But let's do this. Aha, never mind. All right. Let's just see what happens. Oh, here we go. So you can see it's doing, so previously, OK, awesome. Yeah, so previously it was just taking the file name and joining it. It was on the write path, not the read path. So again, if I had this demo prepared, I could have shown you how you could like overwrite files in your home directory with this. And I just didn't see that. So the Snyk analysis found that. It now fixed it. It does this sanitization by just doing path.basename. And now it's running it again. Well, it's thinking. Any other questions? Have folks been able to get this installed? Yeah. Oh, OK. Sorry. All right. Someone else gets chocolate for every question. Yeah.
So, question about your Snyk.
Yes.
Does it scan only does it do only the static analysis, or does some kind of a port analysis on a running container?
Yeah, so we have a whole, I'll call on Ezra if he wants to give the full pitch. Here we're only showing the static analysis and the static composition analysis. We also have a Dast thing that will then go dynamically probe your applications. We call it probably, and then find stuff. There's also container scanning. We have all these new AI tools as well that we're going to talk about a bunch this afternoon with the Evo launch. So there's a whole, so I mean, I think it's probably long gone in the history, but all of those Snyk tools, those are different ways of evaluating your applications and your code.
Are you currently running anywhere in a cloud or only on other installations or like any platform or infrastructure?
Yeah, so we have a SaaS offering. So how this works is we do part of the computation on the client, and then we upload basically the results of the dependency graph analysis and the first parse of the code. And then on our backends, that's where the actual static analysis engine lives, and that does that. And then you can also do stuff. So again, we're showing like a synchronous a workflow here where you're actually in the loop, but you can also, for example, hook this repository into our SCM integrations, and then we'll do, whenever someone sends a PR for your code, we'll then run an analysis on that and say, you're introducing a bad package, or you're introducing a buffer overflow. And then we'll also do periodic scans. So we'll say, oh, we can monitor this and say, well, yesterday, zlib version 5 was fine. Now there's a new CVE. We'll email you and alert you to that. And tomorrow, again, going back to that other slide, we'll have then these autonomous agents that are then fixing it for you and then sending you the PRs so that you don't even have to worry about doing the fixes.
How deep it can go? Like it can go to the OS level and the libraries level, or like even beyond that one?
Yeah, so it does. It depends on the ecosystem. So we have the two sort of the two products in this vein are the SCA product here and our container product, which do very similar types of analysis, but at different levels. So like the SCA, what we call open source, is analyzing your actual application. If you then give it a container image, on our container product, it does the same type of analysis, but it's then looking at everything that's inside of that container, all the binaries installed, all the libraries, et cetera. Yeah. Yes, yeah. So we have, I won't demo it here because I'm not confident in my ability to get the command line flags correct. But yeah, so we have a bunch of different ways of generating SBOM. So for those who don't know, an SBOM is a software bill of materials. And basically, that's that intermediate step that we were talking about, that here's my application, here's all the stuff it depends on, right? And there's that, like, I wish I'd include it. There's that famous XKCD that's like the whole internet, and it's like this pile of blocks. And then there's like one little block in the corner that's like that one random library that some random person in the middle of nowhere is maintaining, and the whole internet rests on it transitively. The SBOM tells you that you, along with everyone else on the internet, depend on that one little library there. So what you can do is, obviously this is a sort of an all-in-one approach. We'll run the analysis, we'll find the vulnerabilities, we'll tell you it all, and you can fix it. There's also ways to hook this into your SDLC. So for example, did it go to sleep? You can generate an SBOM and then store that, feed that into other static analysis tools. You can sort of interoperate with that ecosystem. Yeah? Yeah, so I will defer to, yeah, what was that? Yeah, so the question is, we have sensitive data. The customer does not want us to train our models on the code. What do we do? The short answer is we don't do that today. I think that like as we develop, I'm going to weasel word this a little bit because like as we develop things, we want to be introducing new capabilities. We'll be introducing like robust controls as we do that. You know, one of the things I think is really interesting working at Snyk is we have access to customers' most important IP, right? This is your source code. That's like, you know, that's the crown jewels. And so the responsibility we have towards that is something we take incredibly seriously. And so providing you robust controls on what type of analysis you're allowed to do. So remember at the beginning I had to go in and enable Snyk code. The reason we have that extra step, which is kind of annoying, is because we want to give you that level of control over what type of analyses run and make sure you understand where your data is going. Do you want a chocolate? Okay. Oh, I'm sorry. Oh, God. I sniped someone. Sorry. Aaron, I didn't give you your chocolate either. There's also a lot of Milky Ways, so anyone can just, I need a t-shirt cannon. Other questions? I know we're almost at time. Oh, I'm sorry. No more throwing. Bring your goggles. Awesome. All right, thank you so much. Hopefully you managed to grab the QR code and follow along or run this on your repos. I would love to hear, any of us from Snyk or otherwise, I'd love to hear what it finds in your code. So that's one of the fun things here because everyone's building their own little apps. It's like the Wild West. So if it's finding fun stuff, let us know. Those are always fun stories. If you didn't manage to grab the link there, just Google, Snyk Gemini CLI. It'll take you to our installation page. Or feel free to grab any of the Snyk folks here to help you with that. Thank you.